So again, a shell script is a program written in shell, a programming language that is very useful to automate different tasks under Linux, and it's basically a series of different Linux commands. This can be very helpful to perform also the same action on different files. Like if you wanna do exactly the same thing on 100 of files, it's better to use this this kind of scripting instead of doing it 100 times. We already saw the power of the echo command that we will be using a lot in the different scripts. So let's start exploring scripting under shell. So I'll invite you on the same time to open your terminal and start writing with the nano command in a file called my first script. I'm not going to do the same right now with my terminal because I want you to write on the same time that I explain the different features if you want to. Otherwise you have everything written here and you can take your time to do it before, and as you did last time you can stop the videos, play with your terminal and then go back to the videos. So a shell script basically starts with a line which is called the shebang, that is an hash, an exclamation sign, and followed by the path to your program, which is the bash here. So the bash is under bin and a bash. And so when the Linux, when the system sees this shebang, it's going to understand that we are dealing with the script, and all the following lines are going to be interpreted as shell commands. So here is a very simple example. I want you to write down 3 different commands. The first one is clear. Remember, the clear command simply clears your screen. So the idea here is to clear your screen so that you will be able to see the result of your script. And then I'm asking you to write 2 different sentences by the echo command. Okay, I'll do that right now before moving to executing a script. Okay, nano my first script, and I'm going to use the shebang before. So the exclamation sign, and then it's been bash, and then the clear command, and then echo my first script, and then echo anything you want, second line or wherever. And to exit again, it's Ctrl X, and you say you hit yes to say yes. You want to save the changes. So to execute a given script, you basically use the point slash to say that I'm going to execute that given script. I'm going to do that in my terminal, so it's point slash, and it's called my first script. So here it's an error saying that my first script, there's no such file or directory. I did a mistake while typing the name of the file. So it's okay, let's copy that. And okay, here is another error, which is permission denied. Remember, we already saw the different permissions on the different files, and here it seems that I don't have the right to execute. Let's check that with the ls -l. So my first script is here, and as you can see, I'm the owner of the file, and I just have the right to read and write, but not the right to execute. So it's time to practice the chmod command. So we can simply do chmod. So here I'm going to add the right to execute to only the user of this machine. So remember, the user, we can use the letter U, and I'm going to add the right to execute, so it's U plus X, and I'm dealing with the file my first script. So let's check ls minus L again, and as you can see, so my first script is here. Now I have the right to execute, so if I go back to that command, it should work, and it worked. So the first command executed clear, so it cleared up all the screen, and then it displayed the two different sentences that follow with the echo command in each line. So remember that the chmod, you can also use the octals, but I used the simple form indicating that I'm changing for the user and adding the execution command. If I wanted to use the octal stuff, it could be chmod 7 for the user, and then we have only the right to read for the group and the others, so it can be 744 to simply add the execution right for the user. It won't modify the reading permission for the others. So okay, yeah, I wrote it down. So alright, so as we said, the shebang is always the sign hash followed by an exclamation mark, and it indicates the beginning of the script. So if the shell sees this, the shell understands that it's not a normal file, it's a script, and all the lines contained in that script needs to be interpreted by the program. And here we specify the program interpreter, and we have to specify the path to an executable program. Here again, it's a shell script, and it's going to be interpreted by the bash. If you want, for example, to write a Perl script, this could begin by, again, the hash, the exclamation mark, and the whole path for the executable Perl. If you don't know where your executable is, you can simply use the which command. Like if you type which Perl, is going to give you the whole path for your executable Perl. And you can check this also if you type which bash, is going to give you bin bash that we have been using here, and this is the whole path for the executable program, which is the interpreter of the shell scripts. So an advice that I want to give you is use variables as much as possible in your scripts. This makes your scripts easier to maintain, and it also reduces the amount of typing. If you are, for example, dealing with a long FASTA, a long name of a FASTA file, if you create a variable in which you store the name of the file, you just have to write it once, and each time you're gonna call the FASTA file, you just use the name of the variable, and preceded by the $, of course, to use the content of the variable, and it makes the script easier to maintain in the sense that if you want to deal with another file, or if you want to deal with another directory, you simply change the value of the variable, and you don't have to browse into the whole script and search for all the places where you have been using that name of the file. I mean, you can simply declare, you can simply create a variable and then call that variable and just modify the value of the variable, and it's gonna be modified elsewhere.